Multicellular organisms, like humans, heal from injuries by detecting an injury, stopping further damage from occurring, and then replacing dead and damaged cells with new, healthy cells. It's a pretty complicated process that relies on a lot of different parts of our systems. So when an individual cell gets damaged, what do they do to repair their damaged walls? There are two parts to recovering from an injury. Wound healing is a mechanism that stops the wound itself, like clotting an open wound or cauterizing a cut. Regeneration is a mechanism to rebuild and replace the missing and damaged components, like the skin growing over a scar or a bone mending around a fracture. Wound healing must occur before regeneration is possible. This is really the basic gist of cellular healing. Stop further damage from occurring, and then regrow the lost parts. Going into more detail though, the purpose of the cell's outer membrane is to protect its precious interior from outside damage. If damaging enough, a rupture in the cell's membrane will start a chemical reaction to repair itself. A singular cell doesn't have a nervous system capable of sensing pain like mammals do. They can't think, ouch, I'm in pain, I must have sustained an injury. So they have a couple of methods to detecting damage, ranging from sensing that the cell is filling up with external molecules, to a sudden loss in mass as the cytoplasm spills out the gaping hole in the cell. As seen in this diagram, a punctured xenopus oocyte will flood the damaged hole with the necessary bits to seal up the punctured hole. And yes, you heard the name right. It's literally pronounced oocyte, as in, "Oh, what's this site?" Oh. The speed of healing depends on the severity of the wound. Think the difference in time it takes to stop the bleeding after getting a paper cut versus after getting an entire arm amputated. Once the hole in the cell has been sealed and its contents are no longer at risk of further damage, the cell will begin to rebuild what has been lost. I don't really talk about this in much detail since the process changes depending on the specific cell that gets damaged. The Calidomonas, for example, will deliberately sever its flowing flagellum if it senses it's in danger. The thinking behind the self-damaging behavior is that since the flagellum is the most exposed part of the cell, losing it allows for the cell to more easily protect its vital interior. This bit may sound a bit like common sense, but the cell can only rebuild itself up to a certain amount of damage. Just like how a human being can't just regrow a new head after an accident with a chainsaw, cells that get damaged past a certain threshold will simply die. So the TLDW of this video is that singular cells heal from injuries in the same way that complicated multicellular organisms do. We both have a network of systems to sense injuries, stop the injury from getting worse, and then rebuilding what was lost to the best of our abilities. Extrapolating this further, it isn't hard to see how this process is similar to a bird repairing a hole in its nest, or to a crew repairing a hole in a sail ship's hull.